have a look at in lesson 90 is combining rational expressions. Now, what do we mean by the word rational? What does rational mean? What does rational mean? It's fresh? Did you just say it's fresh?
Fractions.
Chase, did you say it's fresh? Oh.
Fractions.
You didn't say that? Yeah, fractions. Rational expressions, guys. A rational number is a number that can be written in fractional form. It's any number that can be written as a fraction. So it's rational numbers are fractional expressions or things that can be written as fractions. A rational expression, now this kind of is going to change things up. We're talking about a rational expression. We're talking about a fraction that has a variable or a polynomial expression in the denominator. We've done this before. We've dealt with rational expressions like this. 2 over x plus 3 is a rational expression. What makes it a rational expression? It has a variable in the denominator of a fraction. That makes it a rational expression. We've talked about things like what x cannot be. What's the excluded value for x in this rational expression? X can't be negative 3 because if x were negative 3, then we would have a 0 in the denominator, which is very, very bad. Okay? It's undefined. Yes. All right. So here's some things. We're adding and subtracting fractional expressions today. So to add and subtract fractions, you must have a common denominator, right? This is from way back, 3rd, 4th grade. You've been adding, subtracting fractions. To do that, you have to have a common denominator. All right? To simplify fractions, you can only cancel common factors, right? Some of you on the test Friday, you canceled terms. Ugh, ick. You can't cancel terms. You can only cancel things that are being multiplied. So to simplify fractions, you can only cancel common factors, things that are being multiplied. And to find the factors, you must blank the numerator and denominator. You must factor them, right? If we're going to find the factors, then we have to break the numerator and denominator up into factored pieces that are being multiplied. So all of these concepts that we've been working on are going to come into play in this lesson. All right, let's dig right in. Here's the first example. Add and simplify the following rational expressions. Okay. Do we have like denominators here? Yes. We do? That's good. We don't have to do anything to make the denominators the same. So how do you add fractional expressions that have the same denominator? You add the numerators and you leave the denominator alone, correct? So when we add these together, and we can because 2x squared and 3x squared are like terms, so we can add these together and we get what? 5x squared over 20x, right?
Can't that be divided by 5?
Not only can it be, it must be, right? We need to simplify the fraction. So 5 over 20 can simplify to
X squared over
1/4.
4x.
And what else can simplify though?
X.
I can cancel an x from the numerator denominator. That leaves me with x to the first. So I'm left with x over 4. It would be okay to write that as 1x over 4 as well, but you wouldn't ever see that as an answer choice. It wouldn't be likely that you would. Okay, now let's go back to the original problem. Let's go all the way back to here. Do y'all notice anything about these two things before you ever get started? You can cancel things, right? You can simplify fractions here. Should you do that when you're adding?
No.
Why not?
Because you can't add them that way.
Yeah, because remember the end game for adding fractions is to get the denominators the same. So if I take this first term, for example, and I cancel the 2 with the 20 and I get a 10, I've hurt myself, right? because now I don't have a common denominator. So I've got to do something to make it the same again. And I'd have to just multiply top and bottom by 2 to get that denominator back to being 20x. Now, you could cancel an x in both terms, but just kind of as a general rule, unless it's clearly going to help us, we're never going to simplify fractions before we add them. Now, if we can somehow simplify a fraction to make denominators the same, then we may do it. But generally speaking, we're going to make the denominators the same, then combine the terms, and then simplify at the end. Okay? Have a look at this one.
Oh, goodness gracious.
What's different about this one?
You can't terms.
We can't cancel. We can't cross cancel. We have binomials here instead of just monomial terms, so we've got polynomials in play. What else is different? We're subtracting instead of adding. Now, how's that going to affect things, Chase?
Well, it's going to make the numbers smaller.
This subtraction sign right here, guys, let's go back to early in the course, and we've talked about this quite a bit through the course. A fraction bar is a grouping symbol. Okay, so that negative sign has to be distributed through that fraction. And that's one of the ways that you make careless mistakes on these particular kind of problems. Now, our denominators are the same, right? And that's good. So I can just combine, in this case, subtract the numerators. So instead of doing this in one step, let me show this step. It's going to be 3a minus 2 minus a plus 6 over a plus 2. Say it again, Robert. 2a plus 4 over a plus 2. Is that going to be it?
We can simplify it.
How do you know we can simplify? You're starting to, you're about to say something related to canceling terms. We can take a 2 out of the top and factor it as 2 times a plus 2 over a plus 2. And now what can cancel? A plus 2's can cancel, and that leaves us with just plain old 2. Chase.
Why is that a positive 6 and not negative?
Because this negative sign at the beginning gets distributed. This negative sign right here, this negative sign, and this fraction bar is a grouping symbol. So everything above and below that fraction bar is one thing. So the negative sign has to get distributed to the a minus 6. And that's, I'm telling you, that's where you'll mess up on these problems if you're not very careful. Anytime there's a subtraction sign there, put that parentheses there so you remember to distribute the negative through the parentheses.
How'd you change that 4 to 2?
Factor it out of 2. Why did we factor out of 2? So you can simplify, because as we talked about in the notes just before the lesson, to simplify fractions you can only cancel factors, common factors. And to find the factors, you factor the expression. 2a plus 4 is a binomial. How do you factor a binomial? You take out a GCF or difference of squares. There's no difference of squares here, but we can take out a GCF of 2, and that leaves us with 2 times a plus 2. Any other questions? Okay, let's look at another one. Yeah, it is. Now, luckily our denominators are the same here, right?
Yes, sir.
So I don't have to, we're not doing anything difficult on these yet. When you have to get common denominators, that's when things get a little bit more complicated here. Here we're just adding and then simplifying if we can. And simplifying algebraic rational expressions involves factoring. Because we're adding, what can we do here? We don't have to change any signs. We just can take this first numerator and add it to that. What do we get when we add those expressions together? Yes, z cubed minus 6z squared over z squared minus 3z minus 18. Now, why did I put an equal sign there? Because we're not finished, right? We have to see if this fraction can be simplified, and we simplify fractions by factoring and canceling common factors. What can I factor out of the numerator of this fraction?
Z squared.
Z squared is correct, and that leaves me with z minus 6. And how do I factor z squared minus 3z minus 18?
You can take out negative 3z.
Z minus 6 times z plus 3 is correct. And we're to a point where we need to be able to factor just about that quickly. What are the factors of negative 18 that add up to be negative 3? Why do we do it that way? Because it's a trinomial. Can't take a z out of anything, because the 18 doesn't have a z. There's no GCF, so I just go straight to the old trial and error factoring. Are there any factors of negative 18 that add up to be negative 3? Yes. Negative 6 and positive 3. Okay, so now we can do what?
Cancel out.
Cancel negative 6, and what are we left with?
Z plus 3 over
Z squared over z plus 3. Can I cancel these z's? Why not? Because the z in the bottom is a what?
term.
Is a term, and you can only cancel factors. You cannot cancel terms. Okay? Okay, can't cancel terms or parts of terms. You can only cancel factors.
Is that everything?
Yeah, we're going to kind of work a little bit more here.
Yes, sir.
Find the sum by getting a common denominator. Now, this is where all the kind of the questions that we've had in the previous units about, excuse me, about the least common multiple are going to come into play. Because the least common multiple is the least common denominator. And getting a least common denominator helps us in simplifying later, so it's kind of good to help to make sure we get the least common denominator. What's the least common multiple between 6h and 2h squared?
H squared.
H squared, and we need a
2.
6. Right? If I were just doing, let's kind of go back here, and 6h is 2 times 3 times h, and 2h squared is 2h squared. Yeah. So my LCM needs a 2, it needs a 3, and it needs the highest power of h. So it needs an h squared. So my LCM is 6h squared. Okay, that's going to be the least common denominator between 6h and 2h squared. Okay, now what do I have to do on the left side over here if I want to have a 6h squared? Multiply top and bottom by h. Okay, because h over h is 1, right? I'm just multiplying it by 1. What do I do on the right side to make that one 6h squared? Top, bottom by 3, just 3, not h, because if I multiplied by h, I would have 6h cubed. I don't need 6h cubed, I need 6h squared. Okay? So then I will have 2h to the 5th over 6h squared plus 12h squared over 6h squared. And what will that give me?
2h to the 5
2h to the fifth plus 12h squared. Why can I not add those together?
Because they're not like terms.
They're not like terms. They do not have the same variables with the same exponents over 6h squared. Am I finished? Why not? I can factor the top. What can I take out of the top? I can take out a 2 and an h squared. And that will leave me with, not plus, h to the third plus 6. And in the bottom, I still got 6h squared. So what can cancel here?
2h squared and 6h squared.
The 2 and the 6 can cancel, right? Leave me with what? 3 on the bottom.
And the h squared.
The h squareds can cancel, and that leaves me with h cubed plus 6 over 3, right? Can you cancel that 6 and that 3?
No.
Why not?
Terms.
The 6 is a term. The 3 is a factor. It's fair game. I could cancel 3, but 6 is a term. It's a part of this thing that's grouped together. That's one thing in the numerator, and you can't break it up and start canceling pieces of it. Okay? All right. X plus 3 over x minus 4. Now, we're subtracting here, so we're going to have to be careful. All right, to find the least common denominator, we have to find the factors of all of our denominators so we can make sure that every factor is represented, right? And the way we're going to do that is we're going to factor x squared plus x minus 20 as, and you can just do this right below, just like this, x plus 5 times x minus 4. Now, how can I make my denominators the same? Can't get rid of it. If I could get rid of it, that would make the denominators the same. So since I can't get rid of the x plus 5 in the denominator on the right, what do I need to do on the left? I need to multiply the left side by x plus 5 over x plus 5, which x plus 5 over x plus 5 equals 1. So I can multiply by 1 anytime I want to multiply by 1. And now my denominators are the same. Now I've got to multiply now. Right? Remember, the fraction bar is a grouping symbol, so that's in parentheses. What's x plus 5 times x plus 3?
X squared plus 8
8x
plus 15.
plus 15. Then, hey, let's go ahead and do this. Minus 2 all over x plus 5. Leave your denominator factored. We're not going to multiply the denominator back together, because that denominator in factored form shows us a lot, right? It shows us that x can't be negative 5 and x can't be positive 4. So leaving the denominator in factored form is very helpful for us. And we might have to simplify at the end anyway, and I don't want to have to refactor it. So just leave it factored. All right, up top, let's see, x squared plus 8x plus 13. And that 13 tells me that that numerator cannot be factored. And that's my final answer. There are no factors of 13 that add up to be 8. So I can't factor the numerator, which means I can't cancel anything because I can only cancel common factors. Okay. All right. We just got a couple more and then we're done.
Is this our last lesson in the book?
Now we'll do one more that's related to this one in lesson 10. I can't remember which one it is. And then unit 10. We'll do I don't know the number, but one more that's related to this. And I told you guys Friday we were leaving the textbook after that unit. I'd forgotten that we hadn't finished the unit. Remember, we stopped one lesson short of finishing it. Are these denominators the same? No, but they're similar, right?
Can't you multiply the first one by -1 to get them the same?
Yeah, I could do that. Or you could multiply the second one by -1, but it would be easier to multiply the first one by -1.
Why can't we just do it the other way?
What other way? You wouldn't want to multiply the left side by 4 minus v and the right side by 4 minus v. That's going to leave you with something that's really nasty to work with. But here's what I need you to notice. I need you to notice what Chase noticed here. These denominators are not the same. They're opposites. So we can multiply by a -1 and make them the same. Because when you multiply the fraction on the left by -1, you get -8 over -v plus 4 is the same thing as 4 minus v. Now they're the same. V minus 4 and 4 minus v are opposites of each other. Now we can combine those. The denominators are the same. What do I get when I add these terms? V minus 15 over 4 minus v. It's very simple if you see it. If you don't see it, you really work yourself hard making this problem. The denominator's the same. So you need to see that v minus 4 and 4 minus v are opposites. X minus 5 and 5 minus x are opposites.
Can we simplify this anymore?
It can't be simplified, can it? Can we factor v minus 15? No, we can't cancel. We can't factor v minus 15, so we can't simplify it because we can only cancel common factors. Okay? Kyle? Good? Okay, I think we got one more we're going to look at. Little word problem here. Now, I don't know if you guys have picked up on this yet or not, but the word problems that look complicated, but they're usually not. That's true on the ACT, by the way. The word problems on the ACT, I encourage you, when you take the ACT next year or year after, read the question before you read anything else. Like, skip to the last sentence and see what they're asking you to do. Sometimes you don't even need the information that they're giving you. You really don't. And you'll have some practice ACT along the way. But this one, we do need the information. A plane flies 2,000 miles with a headwind that makes the return trip with a tailwind. Write and simplify an expression for the total time of the round trip flight, assuming that the wind speed W remains constant and the plane's averages 500 miles per hour. All right, so the total time. What formula is in play here? We're talking about distance, we're talking about rate, and we're talking about time, okay? So distance equals rate times time is the formula that's in play. And my iPad's messing up here. Distance equals rate times time. But this says to write an expression for the time. So if I'm going to do that, I need to solve this for time. How do you solve this equation for time? You divide both sides by r. So distance divided by rate is equal to time.
Where does W fit into all this?
W is the tricky part of this, and this is maybe a little bit complicated because of that. It says that the plane flies with a headwind and makes the return trip with a tailwind. The headwind means that they're flying into the wind. The wind is working against them. Okay? So the rate on the way there, the speed is, let's see, distance is 2,000. The speed on the way to the place is 500. And because they're flying into the wind is working against them, it's 500 minus W.
Equals T.
That's the time going. The total time is the time going plus the time coming back. The time coming back is 2,000 over. Coming back, they're flying with the wind helping them. So the rate is 500 plus W. Now, to get a common denominator here, it's going to be what? 500 minus W times 500 plus W. I just have to multiply the two denominators together. So on the left, I would need to multiply by 500 plus W, top and bottom. And what do I multiply by on the right? 500 minus W.
Then why would we? But they're opposites.
They're not opposites. They're conjugates. They only have one sign different. And then from there we would distribute here, distribute there, combine like terms in the top. And this problem's a little advanced, I think,
Should we skip it?
because of the concept of the wind speed requires you to kind of know how that works, right? It's a little out of the blue. We're not going to finish it, but that's how you would work that problem. Here's your homework.
Don't do ours.
13 and 26 are not for you guys.